So in this video, I'm going to go over what you need to know for Surds, along with some example questions for the Cambridge IGCSE additional math course running from 2020 onwards. So I'm going to start with some basic rules of Surds, such as for addition and subtraction and multiplication and division. So if you have a Surd, such as a square root of b plus c square root of b, as long as you have the same kind of surd, like the square root of b is common to both here, you could just have a plus c in brackets times your square root over here. And then it's basically the same thing for the subtraction, except it's going to be with subtraction, not addition. Multiplication and division is a bit different. If you have the square root of ab, this can also be written as the square root of a times the square root of b. And basically same thing for the division. If you have the square root of a divided by b, this can be written as the square root of a divided by the square root of b. So we're going to start with a really easy example, which is simplify the square root of 5 times the square root of 15. So we're going to use the multiplication rule we mentioned just before, which is the square root of ab can be written as the square root of a times the square root of b. So we're going to use the rule above, and we get that the square root of 15 times the square root of 5 gives us the square root of 75. So this can't be cancelled down anymore. So we want to find other ways of getting to the square root of 25. One of which is by getting the square root of 25 times the square root of 3, which we're going to use because the square root of 25 is just 5, so it can be cancelled down. And when we do cancel this down, we get that the square root of 75 is the same as 5 times the square root of 3, which is as much as you can simplify it. So we're done with that question. I jump straight into another one, which is open bracket 1 plus the square root of 3, close bracket, open bracket, 2 minus the square root of 8. So the first thing we're going to do is we're going to times out the bracket. So we're going to use the smiley face method, which is, we'll start by going 1 times 2 is 2. So we can put that right here. 1 times negative the square root of 8 is minus the square root of 8. And then if we do the square root of 3 times the square root of 2, that's 2 times the square root of 3. And then the square root of 3 times minus the square root of 8 just gives us minus the square root of 24. Next, we want to simplify the surds that we've just gotten over here. So we're going to find ways to do this. 2 can't be simplified down anymore because it is just an integer. Although we can simplify the square root of 8, as it can be written as the square root of 4 times the square root of 2. And we can also cancel down the square root of 4 even more to be just 2. So we can write the square root of 8 as 2 times the square root of 2. 2, the square root of 3 can't be simplified down anymore, although, so we're just going to leave that as it is. The square root of 24 can also be written as the square root of 4 times the square root of 6. And again, we can cancel down the square root of 4 again to give us 2, meaning that the square root of 24 can also be written as 2 times the square root of 6. So all the simplifications that we just found can be put back into this original line. And when we do that, we get 2 minus 2 the square root of 2 plus 2 times the square root of 3 minus 2 times the square root of 6. And this is as simplified as it can get. Next thing you need to know how to do is to rationalize the denominator. So you would do this when you have a fraction with a surd denominator that you want to use to do further equations with, or tidy it up, or really just maybe because they asked you to do it in a question. So what you want to do for this is you want to cancel out the surd on the bottom. And you have a rule here, but we can't use this for our first example as we don't have the a plus or minus here on the bottom. We just have the square root of 2. So in this first example, we have 1 over the square root of 2 that we want to rationalize the denominator of. In order to cancel out the surd on the bottom, we want to multiply the whole equation by the denominator. So then we end up with 1 over the square root of 2 times the square root of 2 over the square root of 2. And this gives us 1 times the square root of 2, just gives us the square root of 2. And then we have the square of 2 times itself, So we just have 2 of those, or you can write it as the square root of 2 squared. And we know that this is going to cancel down to just give us 2. So we are left with the square root of 2 over 2. Examples actually in the format of the rule I had in the last slide. So we're going to use this. I've just put it at the top here to solve our next one. So the question is, write 1 over 5 plus the square root of 2 in the form a plus b square root of 2, where a, b, and c are part of q. So we take our original thing and we want to use this formula. So we're going to, instead of having 5 plus the square root of 2 on the bottom, we are going to make it 5 minus the square root of 2 on the bottom and times everything by that, as seen here. So 1 times this whole line on the top is just going to be this whole line on the top. And then 5 times 5 is 25. The square root of 2 times minus the square root of 2 is just 2. And then the 5 times minus square root of 2 and the 5 times plus the square root of 2 are just going to cancel out to be 0 anyway. End up with this here, so we're just going to clean it up a bit. 25 minus 2 is 23, which gives us the denominator. And then we can put each individual element over 23, so we have 5 over 23 minus 1 over 23 times the square root of 2, which is our answer.